In this video, I want to talk a little bit more about page faults, specifically what they are, some optimization we can do for them, and the overall system for handling them. Now the first thought, right, is, what is a page fault? We talked about this before. Basic idea is a page fault represents a program wanting to access a page where that page isn't memory resident, right? If it's not memory resident, I can't act on it, right? I need somehow to deal with it. Before we talked about the idea basically of demand paging as well, right? So I was basically loading pages on demand. There's actually a further term, right, which is called basically pure demand paging. Pure demand paging, just a kind of a side note, is basically a technique where we mandate, right, that every single time, we mandate that stuff is only brought to main memory, right, when it's asked for, right? That's the only time it can be brought in. Maybe ask yourself, is that a good idea or not? So in this case, maybe not, right? The issue with that is that basically you get page faults all over the place. Maybe it makes sense, right, somehow to kind of pre-catch the program, right? So for example, that the first, like the main method, right, that's always going to run. Maybe there's a few things basically you can tell ahead of time. These are, it's either the main or like global variables. You can look at those and basically say, I know those are going to be used by people. Let me go ahead and preload those, right? So sometimes, pure demand paging isn't the best, right, just because it forces us to have so many page faults, right? And maybe we can do a little bit better. For now, right, we'll kind of just assume we are on a pure demand paging model, right? But there is some little improvements we can do there. So let's take a look at this diagram and kind of trace out the process. So initially, right, your program is running, and your program wants to run some sort of an instruction. So here, right, we're saying it's in like a load instruction, right? So I'm loading some bit of data. So initially, what I have to do, right, is I have to go and say, okay, I'm going to go look for that page, right? So I have this kind of reference operation. I need to go look up some memory, right? So I go to the page table. And our page table, right, we basically say, hey, does it have a invalid or valid bit assigned, right? What does it look like? Is it available in memory or is it not available in memory? Now, if it happens to be the case that it is there, we're good to go, right? There is no kind of paging that's required. My information is there. I can just run that command, no problem, right? And in fact, I can basically just skip the entirety of the diagram. So let's suppose for a second, though, that it's not there, right, that invalid bit is set to 0. What do I do? Well, basically what happens, right, is I need to basically, pause my instruction, right? So I'm kind of going to end up triggering a trap, right, that basically interrupts my operations that's running, right, so that I can basically load the memory that's needed, right, so that instruction can actually continue its execution. I need to kind of freeze mid operation essentially. So that occurs, right? So the operating system, right, gets told that somebody requests this memory, you got to go handle it, right, bring it in so the instruction can continue running. So that's kind of the second step here, right? And then our page, right, we know our page has to be in the backing store, right? I mean, it has to be somewhere, right? And if we triggered basically the trap, right, basically we have the kind of knowledge that it wasn't available in main memory, it has to be available somewhere else, meaning the secondary store, probably your hard drive. So we go there, right, and we basically look it up and see, where exactly is it being stored. And then, right, we basically can bring it into main memory. Now, as a note here, one thing that's not really shown in this diagram is this notion kind of a victim page. So over here, right, this is technically the victim. So the victim page is basically the one that's going to be replaced. Normally, or well, what we hope for, right, is basically that I have some empty space, right? So I have some empty frames in my main memory, and one of those I can basically just pick, and basically move the new thing that I've just loaded up from the hard drive right into that space. That's what we want to, right? That's kind of the easiest thing to do. But sometimes, right, all my main memory is being used, all those frames have something in it, in which case I basically need to pick some sort of a victim, right? A victim frame, right, is basically a frame that I'm going to say, you know what, I need to put something in your place, so I'm going to basically delete you, probably move you back to the hard drive, and then put something new in your place. Here we're kind of just assuming that there's some empty spaces, and I can just arbitrarily pick one of those and use that as my free frame to put something new into. Otherwise, I have to pick the victim. So that's our step 4, right? So we bring in our new page, right? Once we have that, right, basically we need to update our page table. I don't know if I would say reset, right? Really, it's kind of update, right? Because now all of a sudden one of our new pages, right, is we have basically a new page available that that we can set the bit to, right, to indicate it's available. Another one, right, basically we'll have to remove it, right, because it got cycled out. And our page table is going to be updated, right? And once our page table is updated, well, then we can restart our instruction, right? Our instruction now has that extra piece of data available, and so it's good to go. So yeah, if we do that, basically follow that process, right? This kind of cycle here, well, what happens is we've basically set up for M, right? We've loaded in what M needed, right? Or what the load operation needed, right? The M data, and it's good to go. Okay, so hopefully that made sense. Again, right, it's just this process to bring stuff into memory. Now, there's kind of one last remark here, right, which I want to talk about for a second. And we kind of mentioned this, well, somehow here in our discussion, right, we had this idea, right, of this, we have some sort of operation, right, and my operation, right, was dependent on something that didn't exist in the page table, so I had to, bring it in. So I had to load M. And this is kind of a very minimal example. Let's think about maybe a little bit more of a complicated instruction for a second, and then I'll talk about this point here. But imagine, for example, that I have this, C = A plus B, okay? And I can, so somehow, right, I can have, well, maybe that's not even the best example here. Let's do something a little bit different. Let me draw this out. So imagine basically I have, I'll see one in a second. I have V1 equal V2 plus V3. 3 different variables, right? Simple arithmetic operation. And each of these resides on a different frame. So now I'm going to say this is where basically my ABC comes from. Okay, so just picture this for a second. Now one thought here, right, that's kind of pointed out in the slide deck here, is that, what happens, so basically there may be some issues if I go to interrupt an operation, right? So an operation here basically is this assignment with the addition. And before basically we kind of got our note there is like, oh, I need to basically, stop the operation before it occurs, right, before it tries to use data that's not available, that way I can load it up and then I can let the thing continue. Sometimes that's not safe. So let's take a look at why it's not safe. So here I have basically my variables available. And what may happen, right, is I may try to basically, run this, entire line, right, this entire operation. And if I try to do that, my little concern here, right, is that I may basically, trigger basically, this whole process, right, to load A, to load B. But somehow, right, there's kind of this. Let me actually make a little adjustment before I continue with this example. So let's kind of erase this a little bit, and we'll actually rewrite this as add of V1 and V2. I know that doesn't, let me try to somehow squeeze in a V1 there. Yeah, that's about as good as it's going to get. So say I have this thing here, right? Basically my V1, it's supposed to be a V2. Basically my V1 equals add of V2 and V3, right? So you can imagine you're running this line. What would happen basically is that you imagine, right, you basically have to load up, page A, page B, and then you run add on it. Right, so this is what would happen kind of in the natural course of things. And add does something, right? Presumably it adds and returns something, right? And then we have to store into C, right? So I end up also loading C. The problem is that sometimes kind of the way these things are implemented is that you can basically restart your operation every time you hit something that doesn't exist. And so if this line was being evaluated, what would happen is we would look at add. We would see that add has two parameters, V2 and V3. So I'll bring in pages A and B that store that data. And then I would run add. And then I would see, oh, hey, add's supposed to be stored into V1. V1 resides on page 3. So I would stop the operation and load page C, and then restart the whole line, right? Run add again. This is a little bit problematic because you have basically the opportunity for a side effect, right? So it might be the case, basically, that add has something else, right? Maybe it counts up the number of additions. And so if I restart that operation, it'll change something else in my system, right? So all of a sudden it acts as, oh, there's 2 additions that happen instead of just 1 because this thing was called multiple times and it had this side effect. So we need to basically be careful about restarting our operations, right? Because there's a chance somehow that if we do, basically restart operation, there is some, kind of change to our system, right? So if this thing was allowed to run once, right, it did something right, and then it has to be, run again because we need to still bring in C, right? It happens twice, right? That can cause an issue, right? It can cause some sort of a side effect in my system. So that is kind of one thing we should worry about a little bit. Having gone through this main discussion, let's talk a little bit more about kind of our selection of pages. So here's kind of a couple of thoughts basically for an implementation, and maybe I'll walk through these with you guys. So first ask yourself, how do you pick the pages to initially load for a process? And I kind of already hinted at this before. See if you can remember, see if you can come up with it on your own. So here the idea is I can probably pick things that I know for sure are going to be used. So this is probably going to be my main method, my globals, my static variables, right? The things that basically anybody can access. And maybe even thinking back about the main method, basically I can imagine, all my program up until the first, jump, right? Up until the first, branch, right? I can load everything up until there, right? So maybe main method plus a bunch of other things. So yeah, I can think about doing all of those things. Another thought, right, is, given a set of pages, right, I have to pick a victim frame, right, because I need to, basically have a space that I can put in my new thing, right? I need to have a free frame available. How do I pick which page to move out? Maybe think about that for 1 second. Here we kind of have a lot of different rules we maybe could use. A sample one would be like least recently used, right? So we want to basically throw out the page that hasn't been used in the longest amount of time because nobody wants that page. So maybe that'd be kind of a fair victim to choose, right? Because we want to bring them back into main memory pretty soon. Well, somehow what we want to avoid there is basically kicking out somebody that I'm going to need to bring back immediately, right? That's what we want to avoid. And there's different schemes to get there, and we'll go through a few of them.